Hi, welcome back to the shop. Indicator stands. We all have them, we all love them, we all use them. But how good are they really? This topic came to my mind when I saw a demonstration from Richard King that he does on his scraping courses, where he shows that indicator stands sag. And just for reference, I want to reproduce this experiment and then I'll show you some other things that you might consider when you're using indicator stands. So hang around. Okay, I have a bar, a cast iron bar with a pretty good cross section, so this is pretty rigid and device, and I have a pretty good quality magnetic stand here, indicator stand, central locking, and I have a 1/100th of a millimeter Mitutoyo dial indicator. This is a pretty new one, so I trust it. And what I'm going to do is I'll set up the indicator against this flat bar and preload the indicator slightly. And set it to a nice even number. Like 0. Normally you would say that's perfect, and yes, this is okay. Why, I will show later. But if you take this and you flip it around, oops, it doesn't show 0 anymore. It's -60 because this whole this indicator stand sags due to its own weight. And when we turn it back in its original orientation, we're back at 0. Under normal circumstances, this doesn't matter. This is only relevant when you use your magnetic stand or your indicator holder in a horizontal spindle, like in a horizontal mill, a boring mill, or on a lathe, to center out the bore. But this is quite a lot of movement there, and even when you just turn it to the side, it sags away. So keep that in mind when you use an indicator. This is a pretty substantial error that were about 4/10 of a millimeter of movement just in this indicator stand. And it's not only with this big articulating arm, it's also with smaller ones, and I will show it to you. Okay, I have my small Noga indicator holder, and I have a 1/100th of a millimeter dial test indicator in here. I will just set it up so you can see what I'm doing. And this indicator holder is pretty good. I like it very much. I use it a lot on my machines because it's very nice and small. Okay, you can see that the stylus is touching and we're at 0. But now, if we flip it upside down, we are at -10. And we go back to 0 when we go in normal orientation. So this happens to every indicator holder. How much? That depends on the sign of the indicator holder and on the lever you're creating between your magnet and your contact point. Okay, here I have this is a pretty expensive Fisso stand without the articulating arm. It's just two rigid bars with a clamping joint in between. These cost a fortune. I didn't pay for it, I got it as a gift, but they are horribly expensive, and you would expect that they are really the best you can get. But physics don't care about the price of a tool, so this thing will also sag. You see that we have 0 and we have contact, so now turn it around. And this one also went off 0 by about 1/10 of a millimeter. So even the super expensive Swiss-made indicator stand will deflect under its own weight when you move it. Okay, here is one last. This is a compact magnetic stand, and these are pretty expensive, and I'm not sure if they are still made, but I like them a lot. They are of a pretty simple design. They have a pot magnet, 2 rigid bars, no fine adjustment, what I like on them, and just a swivel mount in front here where I can mount in a normal 8mm indicator or a dial test indicator with the dovetail mount. So let's see how much this will deflect. We are at 0. I'll turn it around. And this one is pretty good. This one only moved about 0.04 of a millimeter. Of course, because the lever is a bit shorter and we have no fine adjustment, which brings flex into the system and so on and so on. Okay, I have again the big magnetic stand here with the Mitutoyo 100ths of a millimeter dial indicator, and I will set up a second indicator here and rest the contact tip on, let me do it so you can see it. And this dial indicator will show how much the big indicator or the big magnetic stand will flex. As you can see, I don't have to exceed any pressure at all to move it. These are super flexible. And I have a screw jack here. Okay, I need to move the setup slightly, so I get the screw jack under here. Okay. The indicator is not actuated right now, and we have the dial test indicator here that shows us the movement of the base to 0, and now we will get some load on this dial test indicator by using this screw jack. I will move it up 1 millimeter. Up to 0, and you can see down here on the dial test indicator that this stand has moved up 0.05 of a millimeter. And if we proceed on, just screw this up, it stays pretty much in place. Because the force of a spring is a constant. It's still slightly moving as the spring or the force exceeded by the indicator is not totally linear, but it's good enough for this for most applications. And as you can see, 9, 10. And we moved in total 7/100 of a millimeter. But as soon as we, how do I say it? As soon as we preloaded this indicator with any given amount of distance, the deflection went up to 5/100 of a millimeter. So we are ranging from 5 to 7/100 of a millimeter. That's 2/100 of a millimeter movement while being in contact with something. And now if we screw it back to to 1 millimeter, we are back at 5/100 of a millimeter. And if we take it completely out, everything goes back to 0. So that's the reason I think almost every machinist knows that you have to get some preload on an indicator before you can do any real measurement. Just watch the dial test indicator when I use my finger on the contact tip of this indicator here. The needle right away moves up to 5/100 of a millimeter and then pretty much stays there. Of course, with the finger I'm exceeding all sorts of forces, a bit of side force, and yeah. But overall, I think you get the idea. Just keep in mind that indicator stands are anything but rigid. And this is not really the cheapest of indicator stands you can get. These are they are sold under this name Atorn, but I think they are made by some major manufacturer for test equipment. Atorn is it's a trademark from a big tool supplier here in Germany. Hahn & Kolb sells these. Okay, let's get a 30 millimeter gauge block under here. There we go. And zero this upper indicator. Okay, pretty much 0. And now drop a 2 millimeter gauge block in there. It should return to 0 2 millimeters more. It should show 2 millimeters more. And that's the fact. So yes, the indicator stand is moving and bending, but for incremental measuring, this is perfectly fine, as the force of the indicator, the spring force, is pretty much constant. And yes, I trust this the small Noga stand to check this, as the dial test indicator has a very low force of a very low measuring force. Shouldn't move much at all. Okay, we're over at the lathe, and I wanted to show you something else. I have a 10 millimeter punch that's hardened ground in my 3-jaw chuck, and I put a piece of 1/10 millimeter brass shim under one of the jaws, so we get some runout. And you can see the runout here on the dial test indicator. We get about 1/1500 of a millimeter runout. Okay, here you can see it a bit better. I get some glare from the overhead light, but I think you still can see it. And now we want to measure how much this indicator by itself moves by when we do this indicating here. We will use this very precise and very sensible 0.002 of a millimeter indicator, also a Mahar. And set it up against the other indicators so we see how much it moves. And when I bring this one in contact with the other, watch the dial on this one. Did you see it? Just moved about a few hundredths of a millimeter. Now we zero out this lower dial indicator and spin the chuck. And as you can see, this dial test indicator shows the runout of our part, and this one will register any movement of this dial test indicator. This is a pretty wonky setup, but I hope you get the idea. And as you can see on this one, there is not much movement. It's about it's not really movement there. Yeah, but we still get our 0.15 millimeters of runout on this one, so we know that we didn't alter this measurement at all. Okay, one last test. I have a 20 millimeter hardened ground precision blah 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 stock in the spindle, and I have the small Noga stand against the chuck with a small dial indicator up here, and the dial indicator is resting against this bar, and if I spin the chuck, of course both are rotating with each other because they are both mounted to the chuck. So, and now if you take a look at the dial indicator and rotate it like this, you will see the problem again. Okay, we start up here. I zeroed it, and now we spin it around. As you can see, that we already have we lost already our zero. Now we go down. So it's fully upright hanging there, and we're about 0.08 of a millimeter off zero. Now we come back on the back side up. We're back at 0.05 of a millimeter, and we're coming back to zero. Almost to zero. There we go. Yeah, this indicator is not really the best. I have my assortment, but you still get the idea. Okay, I changed to the dial test indicator again, and because this is more sensible and more precise in my mind, I zeroed it, and when I bring it around, you should be able to see that we already have left our zero position to -3, and when we go down, this gets a bit hard to see for you, but you see that we are completely off zero now, about 0.05 of a millimeter, and when we come back, it will return to zero. So this whole the indicator stand is sagging all over due to its own weight, and the more reach you have, the more you will sag, because the longer the lever, the higher the torque, and so on and so on. So be careful. So, what's the point? Indicator stands are flexible. They stack, they bend under their own weight, and they bend by the force of the test equipment you use. But most of the time it just doesn't matter, because the measuring force is constant, and that means that you don't change the flex in your system by any means, not really. But when you do this and you work with changing orientations, like indicator on a horizontal milling machine, what I showed you over there on the lathe, that's when you have to be a bit careful. That can ruin your day under some circumstances. So I hope you enjoyed this short episode, and let me know what you think down in the comments maybe. Thank you for watching.